Now let's talk about motion, and we'll start with the very first and basic type of motion, that is motion in a straight line. Okay, so right now I'm doing motion in straight line. This is a topic in which we are going to get clarity about what is distance and what is displacement. Now, suppose an object starts from this point A, it goes 90 kilometers till point B, okay? Then it came back 60 kilometers to point C, right? So what is the distance covered by the object? Distance covered is 90 plus 60, which is 150 kilometers. So distance is 150 kilometers. But what exactly or where exactly is the position of object from the starting point, that is the reference point, origin? It is at a distance of 90 minus 60, which is what? 30 kilometers from the starting point. This is the basic difference between distance and displacement. That is, distance is the total length of path covered by the object, whereas displacement is the shortest distance between initial and final positions. So you must write down the definitions right now. First start writing about distance. Distance is the total. I'll keep on dictating you the definitions. While you're watching this video, keep a note with you and write down the definitions, so your notes will be prepared as simultaneously you are watching this video, and it will help you a lot. So we'll start with distance. Distance is the total length of path covered by the object, whereas displacement is the minimum or the shortest distance between initial and final position. So if I am taking 2 steps forward and 2 steps backward, that means the distance covered by me is 4 steps, 2 front and 2 back. But the displacement is, I'm back to the original position, the displacement would be 0, right? So pertaining to this definition of distance and displacement has a very basic difference that I'll mark out the differences. First is, this is total length of the path covered by the object. This is the shortest distance between what? Initial position and final position, right? Now distance has to be always positive, but displacement could be negative, positive as well as 0. How? See, consider this object starting from A. It has initially gone 10 meters up to point B, and it has now came back 10 meters towards point A, back, okay? So distance in this case would be 10 plus 10, which is 20. But displacement, initial and final position are the same. That means displacement would be 0. Displacement is in this case is 0. Or if the object did not stop at the A point itself, from B started and it covered 20 meters. So this complete is 20. Stopped at point C. So this time the displacement is what? What is the minimum distance between initial and final position? It is 10 in opposite direction, right? Object started moving in this direction, and now the final position is towards southwards of the initial point. So this is 10 meters in the opposite direction of where it started. So we can either tell it negative 10, or we can say that it is 10 meter, but the direction is reverse to that of where it started, right? But this sign conventions is not applicable as per your syllabus, but this is a fact that you should know, so that it will be easier for you to understand the topic when you will be going to higher classes. Now, motion in straight line, we are studying distance and displacement. The basic difference is clear. Okay, so now we are going to study about, we have done distance and displacement. So now we will study about speed and velocity. Distance is total length of path covered by the object. Displacement is the shortest distance between initial and final position. So speed is distance upon time, whereas velocity is displacement upon time. This is the basic difference between speed and velocity. So now you must be understood that the distance and displacement changes its value only and only when the object changes its direction of motion. That means till this point to this point, if I'm walking, the distance and displacement will be same, but if I go back from the initial direction, the moment I change the direction of the motion, the distance and displacement will get different values because the shortest distance changes. So therefore speed and velocity will also have the same value unless and until the object changes its direction of motion. You will get this concept with a very easy example. Suppose a man is walking, he is walking in the evening. How many of you walk in morning and evening? I guess no student do that, right? But everyone, this is a very personal opinion. Everyone has his different reason why he doesn't do walking. Anyhow, we are not consider about that. There is a person who is walking around a square path of length, say 20 meters. Okay, so he's walking this 20 meters, 20 meters, 20 meters, and 20 meters. Now he's covering this 20 meter in 10 seconds, again this 20 meter in 10 seconds, this 20 in 10 seconds, and this 20 in 10 seconds. From A to B, B to C, C to D, and D to back A. I want to write the value of distance, displacement, speed, and velocity from points A to B, A to C, A to D, and back A to A. Alright, these are the values I want to write. So let's start. First of all, from A to B, the distance is from A to B is 20. Displacement, the minimum or shortest distance again is also 20. So we'll write it with units. Speed, distance upon time, that is 20 upon 10, which is 2 meter per second. And velocity, displacement upon time, which is 20 upon 10, again 2 meter per second, right? Now from A to C, the distance is 20 plus 20, which is 40 meters. But displacement here is this much, because displacement is the shortest distance. So from A to C, the displacement is AC. So from the square path, you can find the diagonal to be 20 root 2. So this time displacement is 20 root 2 meters. So speed is 40 upon total time taken is 10 plus 10, 20. So 40 upon 20 will give you 2 meter per second again. Whereas velocity is 20 root 2 upon 20 will give you root 2 meter per second, right? Now from A to D, distance 20 plus 20 plus 20, which is 60 meters. Displacement is the shortest distance between A to D is this point AD, which is what? 20, right? And speed 60 upon 30, which is again 2 meter per second. And velocity is 20 upon 30, 10, 10 and 10, that is 30. So 20 upon 30 is 2 upon 3 meter per second, right? Lastly, from back A to A, distance is 80, displacement 0, right? Because initial and final positions are same. So speed again remains same, whereas velocity becomes 0 because displacement is 0. So this is the basic. Now you have understood the difference between distance, displacement, speed and velocity, because this is the most important information you should know about at the beginning of this chapter, and it will help you understand the further topics very easily. So one thing very important which you should know by this time is, I'm removing these two. What do you get? An object is covering equal distances in equal interval of time, and hence it is having a constant value of speed. This type of motion is called uniform motion. So this is your new definition. Write it down. Uniform motion is when an object covers equal distance in equal interval of time. So what would be non-uniform motion? Non-uniform motion would be unequal distance in equal interval of time, right? So now we have done speed, distance, velocity, displacement. So now we will proceed for motion in a straight line only, but this time we are going to do a new thing about average and relative speed.